Alright, so Unit 3, Day 2, we're looking at transformations and a bunch of rules that we're going to learn that shows how functions change. Okay? After we learn all these rules, I'm going to try to condense them to 3 major rules with one little caveat, one little warning, okay? And it should work for every single function. It doesn't matter whether it's absolute and all the other ones that you're learning this year, because you're learning a lot of functions this year, okay? Alright, so the a value is a vertical stretch when a is bigger than 1. That means you are stretching vertically, and a is a number that's in front of x. So my equation that I'm going to be talking about today looks like the following for the absolute value. Y is equal to a absolute value. You have like a b in here with an x minus c plus d. I know it's a lot, but I will make it easy for you, okay? So a is multiplying this whole absolute value piece. B is multiplying inside. C is either subtracting or adding. And D is either subtracting or adding. Okay? So what you did with your groups, or the partner that you got assigned to just moments ago, addition and subtraction do something, and multiplication and division do something different. Okay? So, vertical stretch. That could be something like a is bigger than 2. So an example could be, bigger than 1. An example could be 2 times the absolute value of x. Okay, go with me? So let's look at the original one. So the original one I'm going to do in black. If I go up 1 over 1, up 1 to the left 1, it almost looks like it has a slope of -1 or 2. Sorry, -1 or +1. And what we're going to do is we're now going to vertically stretch this by 2. Okay, so that means it's going to stretch vertically. So here's a good kind of visual for you. This graph, if I stretched it, will do this. With me? What did it look like? What did it look like it did? It looked like it was closing up, right? It was steeper. Okay? If I don't stretch it, let's say that I compress it, it would do this. I'm vertically changing it right now. These are all vertical changes. And it all falls in either vertical, which is y, which is up and down, or horizontal, which is x, which is left or right. Those are the 2 main categories that all of this information today falls under. Okay? So a vertical compression looks like I just squished it. Like I'm this huge giant, right? Whatever. And I just squished the graph vertically. So I squished it down. Stretching it is like if I were to pull this apart. So if I'm stretching it, it's like I'm pulling this apart and making it steeper. Okay? And then the other ones are just simply shifts, which are translations, which are just slides. Okay? So if I looked at, again, the absolute value function, a shift could be this. Shift to the left, shift to the right, or shift up or down. Are we good? And last but not least, reflections. Reflections are like when you look in the mirror and you see your reflection, you need that mirror there. And let's say that I was reflecting this across this line here. So a reflection would look something like the following. Let's see if it'll let me do it. Yeah. So a reflection would just basically reflect across but end up down here. You with me? And you can do that horizontally as well. Those are the big things that we're looking at today. Okay? Alright, so let's go back to our notes. So this is going to stretch vertically to where the rise over run is no longer by 1. It's now by 2. Okay? So I can look at this almost like a slope. It's not y equals mx plus b, but I can look at it like that. So I will go up 2 over 1, up 2 over 1, up 2 over 1, so on and so forth. And I'll go up to the left 1, up 2 to the left 1, so on and so forth. And in red, you just saw the graph of 2x, or 2 times the absolute value of x. Yeah?
So that would mean like it would be vertical stretch by a factor of 2.
Perfect.
Okay.
That's exactly how it's going to be worded. Vertical stretch by a factor of 2. Now, A is between 0 and 1. A lot of people think that since this was greater than 1, as long as this is less than 1, it's going to be a compression. But it's not. What if it was negative 8? That's not a compression. It has to be between 0 and 1. So visually, when I was your age, I actually had to write out 0 and 1, and it's basically going to be a fraction that exists in between those, but not 1 and not 0. Because if it was 0, what would happen? It just 0 out. What if it was 1? Nothing would happen. It would just stay the same. If I multiplied your height right now by 1, nothing happens. But if I multiply your height by 2, you just vertically stretched. You with me? So A is bigger than 1. Okay? If it stretches. If it's between 0 and 1, it will be a compression. And an example of this looks like that. A fraction that's between 0, aka positive 0, and positive 1. Okay? And I know there's no positive or negative 0. I'm just trying to show and explain to you that it's right here between 0 and 1. So a vertical reflection is if A is what? The way I want you to read this going forward, instead of saying it like an inequality, A is less than 0, I would rather you say A is negative. Okay? So if you're less than 0, now for this unit, I want you thinking the word negative. If you're greater than 0, I want you thinking positive. So if A is negative, the graph would look something like negative absolute value of x. Okay? So let's go ahead and graph what these look like. So the original one that has a slope of up 1 over 1, up 1 over 1, that's the reflection. And then the other one, which was blue, is going to have a slope, right? A slope of 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. Up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And you can see, like that giant analogy that I showed, that if you compress it, it makes it wider. If you stretch it, it makes it narrower. And if you multiply it by a negative, you just turn it and reflect it.
So for the vertical compression, we write it like vertical compression by a factor of 1/2.
Perfect, just like that. Yeah. All right. Let's go ahead and do that right now because, I mean, I think you guys are with him as well as far as going to that level already, and that's fast. So I want you to write right here in words, I want you to write this is a vertical stretch by a factor of 2. This one, I want you to write a vertical compression by a factor of 1/2. And guys, compression to me, so vertical stretch and compression, right? I kind of think almost like this is just me being visual. So let's pretend that I drew an awesome accordion. So an accordion, when I'm stretching it, you're just pulling that accordion out, right? And when you're compressing it, you're just squeezing that accordion in. You with me? All right, so there's thinking of compressions versus stretches. Cool. Or slinky as well. Yeah, slinky as well. So let's say that you had a weight at the end And a vertical stretch would be this. A vertical compression would be that. Actually, the way that I drew that, I don't like that. Let me fix that. Sorry, I'm just now being weird. But anyway, so let's say that this is here. This is my block of where it's going to be located. And a vertical stretch will look like this. Right? And a horizontal one would be the same. Y'all with me? Compression stretches. I just want to make sure that it's locked in immediately. Alright, and then this one is some people say that you don't need it. I say just write it just so that you don't make a mistake of saying the wrong axis. Vertical reflects, or vertical reflection across what? The x-axis. Which makes sense, because if you're vertically reflecting y-wise, you're going across x. And if you're horizontally reflecting, you're going across y.
Is it possible like perform a reflection and a stretch or compression at the same time? So like if it was like reflected by a factor of -3.
So here's what I'm going to say. The -3 part, instead of, you see what he just said? He goes, what if you had like a -3? I would want you to look at that as two things rather than one. You with me? Because -3, does it belong between 0 and 1? No. It is less than 1, but it's not between 0 and 1. So I don't want you thinking about it just as one thing. I want you thinking of the negative as a reflection and the 3 as a stretch. You with me? Okay. Alright, so let's move on to our next example. The B value is different. Okay? So the way I want you to kind of think about this, so far we followed intuition and we followed the rule. This is like me leading you to the shortcut that I'm trying to give you at the very end of the note. And over here, the B value, I said this last class, is with the x. Okay? And just the x. Think of it however you want. Ex-boyfriend, ex-girlfriend, ex-husband, ex-wife, whatever. Okay? You are doing, or you're interpreting the opposite. And to me, it's a good reason to know, yeah, if I'm with X, I'm doing the opposite. That's why that X is my X, because I was doing the opposite of what that person wanted. But if I'm not with the X, I follow the rule. Always. Okay? So now, here we go. B is this value right here. And if B is 1, immediately, what's the very first word that you think I want you to describe the transformation? The very first word. Horizontal. So all of these over here with the y value outside of the x, they were all vertical. Okay? And that goes back to what I was showing you at the very beginning. Vertical versus horizontal. Vertical meaning up and down, horizontal meaning left and right. Okay? So this is going to be a horizontal. Guys, if B is bigger than 1, we learned just moments ago that if I'm bigger than 1, what does it look like it wants to do? It looks like it wants to stretch. You with me? But because it's with the x, it's not going to be a stretch. It's going to be a what? A compression. You with me? So you're going to show something, like let's say that I wrote y is equal to 2x on the inside. The first word you're going to write is a horizontal. That 2 looks like it's stretching, but we're with the x, so we're going to do the opposite. So it's a compression, not by 2. Who said that? Nice, by 1/2. Reciprocate that. So whatever that fraction is, do the reciprocal. Flip it. So compression by a factor of 1/2. Okay? Does that make sense? Okay. So now let's go over here and say, what if b was smaller than 1 but bigger than 0? So what if I had an equation that looked like 1/2 x like this? What's the first word that I write down? Horizontal. Because it's with the what? It's with the x. So it's a horizontal. At first glance, that 1/2 looks like it's going to be a what? Compression. But we're with the x. So you're going to do the opposite. So it's a horizontal what? Stretch by 2. And you could say 2 over 1. Horizontal stretch by 2. By, whoops, a factor of 2. Okay? And then the horizontal reflection, when b is less than 0, so in other words, if you had, or b is negative, you would have something that looks like this. And what does that reflect across?
The y-axis.
The y-axis. Because it's a horizontal reflection. And do that with your hand if you need to. You're reflecting across the y-axis. Okay? So we'll say horizontal reflection across the y-axis. Okay? So let's do, in green, this last one. So if I reflect across the y-axis, how does the original one change? It doesn't, right? It doesn't. What used to be here is now going to be over here. And what used to be originally over here is going to now be over here. So nothing changed. I mean, it reflected, but the graph still looks the same. Okay, so now let's look at the horizontal compression by a factor of 1/2. Okay? So what's going to happen?
So the slope is going to increase, basically. Whenever you're graphing, the slope's going to increase.
So if I do a horizontal compression, that's what this is, right? We said it's a horizontal compression. I want you to think of the graphs that we did. Okay, you ready? Here we go. This is a vertical stretch. Do you see what's going on? All right, so let me show this 2 different ways. A vertical stretch, we'll do that. A horizontal compression, we'll do this. Do they look the same? They do. They do. You see what I'm saying? So whenever I go back, it will look very similar to what the other one could be, but it's a different way of looking at it. Okay? So let's go ahead and graph this. At 0, it would be 0. At 1, it would be what? 2. At 2, it would be 4. Y'all with me, guys? And then it's just going to have a slope. Still, it looks like it still has a slope of 2. But it wasn't a stretch. It was a horizontal compression. Y'all with me? All right. So this would also be the same. Now let's go to this last one. This one is a horizontal stretch by a factor of 2. So at 0, what is it? 0. At 1, it's 1/2, and I'm not going to graph that. But at 2, when x is 2, what will my answer be? 1. When x is 4, what will my answer be? 2. So it makes it wider. So a horizontal stretch looks the same as a vertical compression. And a horizontal compression looks the same as if it was a vertical stretch. Okay, good stuff. Any questions before I keep going? Okay, so that's A and B, the multiplication stuff. To me, I think that's the most difficult.